Hello students, welcome to next video. Today we will learn about continuous function. Till now we have learned continuity of a function at a particular point, but here we will learn about continuous function. So what is a continuous function? If a function is continuous at every point of its domain, then the function is called a continuous function. That means if a function is given with its domain, then if that function is continuous at each and every point of the domain, then that function is said to be continuous. For example, if a function fx is there and if its domain is open interval 0, 1, and if this function is continuous at each and every point on its domain, that is in the points lying between 0 and 1, then we say that this function is continuous at its domain. So here's some note we have to remember. So note number 1, every constant function is continuous. So constant function means, like for example, let fx equals to 5. So here this is a constant function because whatever the value of x is, the range is always 5. So this is a constant function and this kind of function is always continuous. Next, number 2, identity function is continuous. Identity function is fx equals to x. So this type of function is also continuous. Here number 3, note number 3, if f and g is a continuous function, then the addition of those two continuous function is continuous and the subtraction of those two continuous function is also continuous. And similarly, f into g is continuous, and number 4, that is f over g is continuous, where gx is not equals to 0. So here it means that if f and g are continuous, then f over g is also continuous, but g of x should not be equal to 0. Note number 5, c into f is continuous where c is any scalar. So if f is continuous and if we multiply this function with any constant c or any scalar c, then that particular c into f will also be continuous. Point number 4, polynomial function is continuous. Every polynomial function is continuous. For example, x square or x cube plus 3. So any polynomial, any degree polynomial is always continuous. Point number 5, rational function is continuous. So here rational function means fx over gx. So here also the gx should not be equal to 0. Exponential function is also continuous. Similarly, logarithm function is continuous. And in point number 8, we have sin x, cos x, tan x functions are continuous. And at last, composition of any two continuous function is always continuous. So in this video, we will do one question. We will try to show this given function is continuous at every point. Let us make a number line and let us mark 0 over here. So this real number has been divided into two intervals. So this side is the portion where x is less than 0 and this side is the portion where x is greater than 0. And we will also show that this function is continuous at 0 also. Okay, so here we will be dividing this question into three parts. So here the function fx is sin x when x is less than 0 and the function is x if x is 0 or greater than 0. That means this side my function is sin x and this side my function is simply x, and at this particular point 0 my function is x only. Let us choose any point on this interval. So let that point be C. So I am choosing a point C, any arbitrary point. That means this C will represent any point which is less than 0. So case 1, at x equals to C, which is any number less than 0. So first we will try to show this function is continuous at this particular point C. And since if we approach C from left or right, the function is same, so we will simply find the limiting value. So here limiting value or the limit extends to C, f of x will be equal to limit x tends to c sine of x, and it will be sine of c. And similarly at c I have to find the functional value also, so my functional value will be f of c, and since the function is sine x, so fc will be sine c. And since my limiting value and the functional value are both coming sine c, that means this function is continuous at c. That is, since limiting value is equal to functional value, therefore fx is continuous at x equals to c. But this c point was any number which is less than 0. That means we can write this function fx is continuous at every point x which is less than 0. So this was my case number 1. Now let us do case number 2, where we will be choosing a random point which is d, and this d is greater than 0. That means this d will represent any number which is greater than 0. So at x equals to d, which is greater than 0. So since here also, if we approach d from left or right, my function is x only. So here we will directly find the limiting value. So here the limiting value, that is limit x tends to d, f of x will be equal to limit x tends to d x. So this will be simply d. And the functional value, that is f of d, will be equals to d, since the function is fx equals to x. So here I found that the limiting value and the functional value are both d and d. That means this function is continuous at this point d. That is, limit x tends to d, f of x is equal to f of d. That's why this function is continuous at x equals to d, and d is any number which is greater than 0. That means we can write in conclusion that fx is continuous at every point x which is greater than 0. So case 3. So my case 3 is at x equals to 0. So the left hand limit x tends to 0 minus f of x equals to the function on the left hand side of 0 is sine x, so it will be sine x, and if you put the value of x as 0, then it will be sine 0, and it will be equal to 0. Similarly, my right hand limit, that is limit x tends to 0 plus f of x, will be equal to limit x tends to 0 plus the function fx is x here, so here it will be 0. So see, the left hand limit and the right hand limit are coming same. And finally we will have to find the functional value, that is f of 0. And as you can see, when the value of x is equal to 0, my function is fx equals to x. That means f0 will also be equal to 0. So what I found is that the left hand limit, the right hand limit, and the functional value are all 0. That means the conclusion is that function fx is continuous at x equals to 0. So my final conclusion is that this function is continuous at every point which is less than 0. This function is continuous at x equals to 0 also, and this function is continuous at every point which is greater than 0. That means this function f is continuous everywhere in its domain.